Now in this video I'm going to compare capacitor and inductor. So here is inductor and here is capacitor. Okay, so they both store energy, but it stores energy in the form of magnetic field, it stores energy in the form of electric field, Okay. Here inductor we indicate with the coil L and measured in Henry. Capacitor indicate with the two plates, indicate with C, measured in farad. Okay, energy stored here, I forgot to write it down here, which is half Li square. Inductor always depends upon the current, capacitor always depends upon the voltage, half Li square, half CV square. Now in DC, if you look into my other video, you can see in DC inductor acts like a short circuit. Inductor acts like a short circuit once it is fully energized. Okay, in DC capacitor, if you remember, in DC capacitor act like a open circuit once it is fully charged. How long does it take to charge or energize? It takes only a few milliseconds depending upon RL circuit. Okay, it takes only few milliseconds. This is valid for both. Okay, to energize the inductor or to charge the capacitor, it takes only few milliseconds. Now L inductance is nothing but phi b over I, C equal to Q over V. Q is the charge, V is the velocity. Sorry, V is the voltage, my apology. Charge by voltage. Next one, the L value, L equal to mu naught N square A over L. L is length of the inductor, mu naught is a constant, N is number of turns, A is cross-sectional area, and C equal to epsilon naught K times, K is another constant, dielectric constant, epsilon naught A over D. D is distance between the plates. Okay, this is in farad, this is in Henry. Another important point, inductor, it opposes rate of change of current. Okay, here it opposes rate of change of voltage. Okay, so when AC voltage is changing, capacitor is going to come into the picture. If AC current is changing, inductor is going to come into the picture. Now when it comes to the RL circuit, okay, please watch another video. So you have resistance there, inductance there. Okay, by the way, it is impossible, I won't say impossible to have pure inductor. MRI machines, I believe they have the pure inductors, because this, remember, this inductor is made with a coil, made with a conductor. Okay, every conducting material will have some resistance. That resistance is rho L by A. So for sure this inductor is going to end up having some resistance. Now in MRI machine, if I use this inductor, for sure it's a very huge big coil, it produces lots of heat. I think it's going to fry the human body. So that's the reason there they don't use these inductors. They use I think helium or something, some kind of gas, to produce the magnetic field there. Okay, but every other, I mean, whatever you see in the market, all those inductors will be made with a coil similar to this. These coils definitely will have some resistance. Okay, so now in RL circuit, okay, RL DC circuit, okay, here is the current. So once I close the switch, that's the current, and VL and VR. How this is going to work, I will explain that in a graph format. So the current, once I close the switch, it will take some time to charge. Okay, so it will start slowly. Once it is fully energized, okay, once it is fully energized, it will act like a short circuit. So here is my current, and that's I naught. I naught is the maximum value, where I naught equal to V over R. Here is the V supply voltage. So this graph, I can say I of t equal to I naught times 1 minus e to the power of minus t over tau. Tau is nothing but when it reaches to 63% of its final value, 63.2% or something like that. So this tau is time constant. In RL circuit, it's nothing but L over R second. This is called time constant. Okay, now the voltage drop across the inductor is going to goes down. This is VL, that's nothing but V naught times e to the power of minus t over tau. Okay, so that's the voltage drop across the this is voltage drop across the inductor, and that's the current passing through the inductor in RL circuit. Now when it comes to the RC circuit, okay, in RC circuit is also we have both plates. Both plates are conducting plates. They have cross-sectional area, so definitely it's going to have some resistance in there. Now when I close the switch at t equal to 0, we are closing the switch. Okay, so to find out in detail, I posted another video. Please watch that video. So here, if I apply DC, this is RC circuit. Okay, so here initially, that's called transient state. Initially, capacitor is going to act like a short circuit for short period of time. Once it is fully energized, it will act like a open circuit. So this indicates that VC equal to V naught, which is the maximum value, 1 minus e to the power of minus t over tau. So this is VC, that's the time, x-axis is the time. Same thing, the tau is the time constant to reach 63.2% of the final value. Now when it comes to the, that's a voltage drop across capacitor, and this is the current. So current in the circuit, I equal to I naught e to the power of minus t over tau. Here I naught is nothing but V over R, where V is the supply voltage. Okay, now here time constant tau, time constant equal to RC. Time constant in RC circuit is RC. So there are lots of comparisons between inductor and capacitor. Okay, so they both store energy. One is in magnetic field form, another one is electric field. One is in magnetic field, another one is magnetic field, electric and magnetic. And these are the comparisons between the L and C circuit. Thank you.